Reuters reported Friday that Alibaba is banning Claude code in the workplace over alleged backdoor risks, and TechMeme's summary of the information says Alibaba asked employees to remove Claude models from work computers. On the other side of the same story, TechMeme's Financial Times item says Anthropic is moving to close loopholes that let Chinese firms like Ant reach its models through cloud providers and overseas subsidiaries. Pause. That is the lead today because the objects are concrete. A coding agent is sitting on an employee machine. A cloud account becomes a route around a national restriction. A model that felt like software suddenly has something closer to customs paperwork around it.
The workstation detail changes the temperature for me. A national access policy is abstract until it shows up as, remove this tool from your laptop before it touches code. And Claude code isn't a random chatbot tab. It has repo context, shell context, maybe credentials nearby. And the whole promise of the product is that it can act inside the work environment. If Alibaba believes there is a backdoor risk, even if the public evidence is thin, the internal response is going to be blunt.
Right, and the public record here has different confidence levels. The Reuters item is a reported workplace ban tied to alleged security concerns. The TechMeme Financial Times item is a reported Anthropic effort to close China access workarounds. The local El Alarme post about the Claude code mechanism and the Anthropic base URL environment variable is background, not proof of what Anthropic intended. I wouldn't build the episode around a screenshot. I would build it around the fact that developers immediately went looking for the mechanism, because that tells you how this kind of restriction is going to be tested in the wild.
And it also tells you why a well-written policy isn't enough. People route around model gates with cloud accounts, subsidiaries, local proxies, alternate base URLs, and whatever their existing toolchain already allows. So the security question becomes, where does the provider enforce the rule? At account creation, at billing, at API routing, inside the client, or inside the model service? Each choice catches a different workaround and annoys a different innocent user.
The Anthropic side gets harder than the headline once you ask how identity travels. If a Chinese parent company can use an overseas subsidiary or a cloud provider relationship, the model provider has to decide how far corporate identity travels. Does the restriction follow beneficial ownership? Does it follow geography? Does it follow the employee's device? The answer changes who gets blocked, and it changes what evidence the provider has to collect. A model company that wants to sell enterprise access now needs some of the muscles of export compliance, cloud trust and safety, and procurement screening.
The Alibaba side has the mirror problem. They are saying two things at once. We don't want this model, and we don't want this model running as a tool inside our workplace. That is a more technical objection. A coding agent can read files, propose patches, call tools, and send code or prompts back to a provider. Even when the model company is acting in good faith, the customer has to decide whether that loop is acceptable for sensitive repositories.
My read is that both companies are acting under incentives that make sense. Anthropic has pressure to show that its China restrictions aren't theatrical. Alibaba has pressure to show that foreign coding agents aren't casually sitting inside its engineering workflow. Both incentives push toward less ambiguity. Providers will ask for stronger identity claims. Companies will ban tools faster. Developers will keep finding the places where the old open API culture meets national security language.
And that is a loss of innocence for coding tools. For years, the implied contract was almost delightfully simple. Set an API key, point your editor at the endpoint, and go make something. This story says the endpoint is no longer a neutral technical detail. It can encode a country's access, a company's trust decision, and a vendor's view of who is allowed to use the model through which cloud.
The recent Anthropic access story belongs in the background here, but the new edition is narrower. Today's access fight moved into the developer workstation. When a tool can operate inside the repo, the ban doesn't stay at the account layer. It becomes an endpoint policy, a device policy, a procurement policy, and a security review.
That also means the open source and local model communities will read every enforcement mechanism as a product signal. If a client reacts badly to an alternate base URL, people using local models will notice first. Some of them are evading restrictions. Plenty of them are doing normal local experimentation. A restriction can be politically motivated and still break a legitimate developer habit.
Exactly. The next evidence that would matter is dry in the legal sense and interesting in the engineering sense. Whether Anthropic documents the client behavior, whether cloud providers get clearer resale rules, and whether Alibaba or another large Chinese firm publishes a technical basis for the backdoor concern. Until then, the strong claim isn't that Claude code contains a backdoor. The strong claim is that Claude code has become sensitive enough for two large companies to treat access itself as a security incident. Blackstone's QTS abandoned its portion of a planned 2,100-acre data center campus in Virginia after years of local opposition and legal challenges, according to TechMeme's Bloomberg summary. IEE Spectrum, in a separate piece by Matt Hassan, argues that AI data centers are stressing the grid through the pattern of demand, not just the amount of electricity. And the Wall Street Journal item picked up on Hacker News says AI data centers use more water than most tech giants report. That is a lot of physical reality for one Friday morning.
The QTS item is useful because it isn't a spreadsheet abstraction. A 2,100-acre campus has neighbors, hearings, lawyers, water pipes, substations, and roads. It occupies a place. AI infrastructure is often discussed like capital can simply summon capacity wherever the model roadmap needs it. Then a county, a court, or a utility gets a vote.
The IEE piece gives the mechanism I wanted. Hassan says the standard energy discussion catches scale but misses behavior. Training workloads are dense and synchronized. Inference is more distributed and user-driven. High-density compute can create rapid changes in power consumption over extremely short intervals, and cooling demand rises with the compute load. So from the grid operator's perspective, the problem isn't only how many megawatt-hours will these buildings use this year. It is what happens when a very large local load changes quickly.
That is a wonderfully annoying systems problem. A factory load isn't trivial, but it is legible. A cluster of accelerators can run training jobs, cool those jobs, and change timing because a scheduler moved work around. The data center can be technically sophisticated and still be a difficult neighbor for the grid because the local circuit experiences the whole workload as physics.
And the geography matters. IEE calls out Northern Virginia, Data Center Alley, as the obvious example. Concentration creates local reliability issues even when the broader system has enough aggregate power. That should discipline the AI infrastructure conversation. A national chart can say generation capacity is coming. The substation near the campus can still be constrained. The town can still object. The cooling loop can still need water.
The water story fits there too, although I would be cautious without the full journal article in front of us. The headline claim is underreporting. AI data centers use more water than most tech giants report. If that holds, the fight won't only be about whether the data center is efficient in a narrow engineering sense. It will be about whether communities can see the resource trade before they approve the build-out. Hidden water use is exactly the kind of thing that turns a permit hearing into a trust fight.
A chip policy item sits in the same cluster. TechMeme's Bloomberg summary says SEMI, with Micron and Samsung included, warned Scott Bessent that U.S. policies affecting prices or production capacity would worsen the shortage. Put that next to the local build-out story, and the constraints get very plain. Land and courts, grid behavior and water reporting, wafers and policy. None of those prove the AI build-out is collapsing. They show that deployment capacity is negotiated with many systems that don't care about the demo schedule.
I like that altitude. The story isn't that the infrastructure boom is over. The story is that the boom has entered the phase where the abstract inputs get names. This substation, this aquifer, this zoning board, this transformer order, this memory supply warning. A lab can buy a lot of GPUs. It can't buy a town's consent with the same purchase order.
AI power now has to be discussed with more precision. If the problem were only total energy, you could answer with new generation. If the problem includes millisecond load swings, local congestion, cooling coupling, and concentration, then the answer has to include scheduling, storage, power conditioning, interconnection rules, and much more transparent reporting. That sentence won't sell a keynote. It will determine whether the model roadmap gets a building to run in. TechCrunch, citing Reuters, reports that Mark Zuckerberg told Meta staff the pace of AI agent development hadn't, quote, accelerated in the way executives expected. The same piece says Meta laid off about 8,000 employees earlier this year and reassigned another 7,000 to AI groups, including one called Agent Transformation. Zuckerberg reportedly said the cuts were not as clean as they should have been, and that the upside from the new AI-focused structure hadn't come to fruition yet.
That is a useful admission, because it isn't coming from a skeptic on the outside. It is Meta saying, inside one of the companies most willing to spend and reorganize around AI, agents aren't moving at the pace leadership wanted. That doesn't mean agents failed. It means replacing organizational work with agents is harder than adding a model to a product surface.
And it sits next to another Meta item from TechMeme's Business Insider summary. Alexander Wang reportedly said Meta's model in training, codenamed Watermelon, matches GPT 5.5 and uses an order of magnitude more compute than Avocado. So the picture isn't simple pessimism. Meta can be saying the next model is huge and impressive, while also saying the agent transformation inside the company has been messier and slower than expected.
That pairing feels more candid than most agent discourse. Better base models help, but the hard part of agents is the surrounding system. The agent has to know when to act, when to ask, what it is allowed to see, how memory should work, which handoff is safe, and how to recover when the world pushes back. More compute helps some of that. It doesn't turn a reorg into a solved problem.
The human piece matters here. If you cut thousands of jobs and move thousands more people into AI groups, you aren't merely adopting a tool. You are asking a company to change how authority and accountability work. Who owns a bad agent action? Who signs off on a workflow that used to be a person's job? Who maintains the prompts, the policies, the evals, and the exceptions? Meta may still get the productivity gains it wants, but the delay is information.
There is also a morale story hiding under the technical one. TechCrunch's article uses some harsh language from prior reports about the AI unit, and even if you strip away the color, the incentive is obvious. A team told to prove an AI transformation after layoffs has every reason to make the demo look good. That is exactly where evaluation has to be independent enough to annoy people. Otherwise, the internal story becomes, the agent works, until it meets the undocumented portion of the job nobody put in the demo.
That gives us a bridge to the eval material, because the day's research items are almost comically well-timed. Meta says agents are slower than hoped. Arvind Narayanan says AI evaluation should become an internal but independent function. Several new papers argue that agents need governed context, deterministic evidence path tests, and better permission designs. The coincidence isn't proof of a trend by itself, but it is a good snapshot of where the pain is moving. Arvind Narayanan wrote Friday that companies already check their own work through internal but independent functions like QA, security red teams, and model risk management in banks. Then he says, quote, I think it's time for AI evaluation to become one such unit. His argument isn't just that evals are important, it is that evals need their own reporting line, because deployment teams have incentives to show success.
That is the most practical sentence in the whole governance pile. If the same team is responsible for shipping the agent and proving the agent works, the eval will slowly become a launch accessory. Maybe not maliciously. People optimize what they are rewarded for, and a team under pressure will choose test cases that match the story it wants to tell.
Narayanan names the skill mix too. AI expertise, domain expertise, customer understanding, statistics, business operations, risk management, and sometimes compliance. That is why this isn't just a benchmark team. It is an organizational function that understands the model and the workplace it is entering. I think that is right, and I think the strongest version of the idea is that evals become part of the institution's memory. They remember how the system failed last quarter. They keep the weird cases alive.
The papers make that less abstract. ContextNest says retrieval isn't governance. It formalizes a layer under retrieval that tracks whether documents are approved, current, attributable, integrity verified, and reconstructible later. The example in the paper is very plain. A procurement agent uses an old risk threshold because the archived policy lived next to the current one in the same index. The answer was relevant. It was also governed by the wrong version.
That example is sticky because it separates two failures people blur together. Retrieval can find semantically similar text and still hand the agent a stale rule. ContextNest proposes typed documents and metadata, deterministic selector queries, hash-chained version histories, checkpoints, and audit traces. I wouldn't treat one paper as the standard everyone will use. But the requirement feels durable. If an agent cites a policy, an auditor should be able to reconstruct which policy version the agent saw and whether it was eligible for use at the time.
GroundEval attacks the same problem from the testing side. The paper opens with a case where two frontier model judges gave a plausible agent response a high score, but the trace showed the agent had never retrieved the artifact its answer depended on. GroundEval's score was 0. That is brutal in the good way. It says, the answer sounding right isn't enough if the evidence path was invalid.
And it is judge-free by design. GroundEval scores what the agent searched, fetched, cited, and was allowed to access. The authors divide failures into tracks like silence, perspective, and counterfactual. Did the agent check before claiming absence? Did it answer from what the actor could know at that time? Did it use the right causal mechanism? That maps directly onto enterprise agent work, where a true answer from the wrong user's memory can still be a failure.
Janus is the permission side of the same conversation. It asks what role users can and should play when agents make tool calls. The paper's email example is simple. Someone asks the agent to forward family reunion details. Is that a legitimate relative or an attacker? The model may not know. A system that asks the user every time creates fatigue. A system that automates every decision cuts out the context only the user has.
So the practical stack starts to appear. Context has to be governed before retrieval. The agent's evidence path has to be testable after the run. Permissions need a design that includes the user without turning the user into a bored rubber stamp. And Narayanan's org chart point says these can't be left as hobby projects inside a deployment team.
That also makes the meta-story feel less like a one-company stumble. If agents are moving slower than hoped, one reason may be that the surrounding institutions aren't built yet. You can buy more compute for Watermelon. You can't buy an independent eval function, a governed context vault, and a permission culture in the same way. Those have to be grown inside the company, which is slower and much more political.
I don't want this to turn into generic advice. Agent capability is forcing old software questions into visible form. Who approved this knowledge? Who could see this document? Who granted this action? Who checked that the answer came from evidence the actor was allowed to use? Those questions used to sit below the surface. Agents make them part of the product experience. 2 shorter items before we close. Epoch AI posted that in June 2026, 21 notable organizations disclosed about 1,500 high and critical severity CVEs, more than 3.5 times the previous monthly record before Claude Mythos Preview's release. Ethan Mollick quote-tweeted it and said the talk about Mythos and cybersecurity wasn't hype. I would treat that as a serious signal and not yet a clean causal claim.
Yes. The number is striking, and the timing is striking, but vulnerability disclosure has many moving parts. Coordinated disclosure cycles, triage capacity, changed incentives, tooling, and who gets counted as a notable organization. The safer read is that AI-assisted vulnerability finding may now be visible in the public CVE stream. The unsafe read is that one model caused the whole spike.
The technical question is fascinating, even if the attribution takes time. If frontier models are finding many more vulnerabilities, the bottleneck moves to verification, patching, disclosure process, and the organizations receiving reports. More findings are useful only if they can be sorted and fixed. Otherwise, the security world gets a flood of plausible danger and a lot of exhausted maintainers.
And it loops back to evals in a different way. A model that finds bugs needs a measurement system that distinguishes a real critical issue from a hallucinated exploit chain. Security teams already live with noisy scanners. AI can make the scanner smarter, but it can also make the noise more persuasive.
The other quick item is Anthropic and custom silicon. TechCrunch reports that Anthropic has been discussing a potential AI server chip collaboration with Samsung, while Anthropic told TechCrunch that a diversified hardware stack including Google, Amazon, and NVIDIA chips remains central to its compute strategy. The report says Anthropic hasn't decided what the chip would be used for, how it would fit into the server, or how powerful it would be.
That caveat matters. This is early stage, not a taped-out chip with benchmark numbers. But after OpenAI's Broadcom inference processor news last week, it makes custom silicon look less like one company's side quest and more like a frontier lab reflex. If you depend on NVIDIA, Amazon, or Google for the floor under your model business, you eventually ask whether some part of that floor should be yours.
And the Samsung angle is a reminder that hardware independence is never pure independence. You trade one dependency for a different chain of manufacturing, memory, packaging, software, and supply relationships. Anthropic can want more control over its compute supply and still need partners everywhere. That is the same lesson as the data center segment in miniature. AI companies keep trying to own more of the stack, and the stack keeps turning out to be full of other institutions.
Which is a pretty good description of the day. Claude access runs into corporate security borders. Data centers run into towns and grids. Agents run into org charts. Security models run into disclosure systems. Chips run into fabs. The technical story is still moving fast, but the people and institutions around it are now part of the runtime.
For tomorrow, the evidence I want is specific. Documented Claude code behavior around alternate endpoints, clearer Anthropic or Alibaba statements on the security concern, and more methodology behind the CVE spike. Friday's lesson is that AI systems aren't escaping the world around them. They are giving the world many more places to say yes, no, prove it, or wait. Lena Kess.